So we're starting a new section today where we make your code easier to debug with functional programming. So in this section, we're going to take a look at number 1, new ways of calling functions with arguments and keyword arguments. Number 2, one-line functions with lambdas. Number 3, segmenting your code with functions within functions. Number 4, creating dynamic functions by returning functions. Number 5, and lastly, powering up your functions by wrapping them with decorators. Let's go in and look at this one by one. So the first thing we're going to look at is focusing on new ways of calling functions with arguments and keyword arguments. So what this means is there are multiple ways to call functions, and we also need to leverage the fact that functions are first-class objects in Python. And I'm going to show you the different variations of how we can call functions. Let's go in and take a look. So we're here in the Jupyter Notebook. So let's focus on how we can have new ways of calling functions with arguments and keyword arguments. So consider a typical function, right? A typical function may look like define typical function. You have parameters 1, 2, 3, and then you do something with it. Let's assume that. So let's just make a quick note of the fact that 1, 2, 3 are all strings. And then let's say the return is. So easy enough. And typical function, if we have Mary had a little lamb, then it would just add the 3 strings together, right? So the trick that I want to show you here is what happens if you need a more complicated way of coming out with Mary had little lamb, because typically in a situation you would do the following, right? Like you would have, somewhere else would have like the start equals to Mary, and you have start, and then similarly you have middle and you have end. But sometimes assigning the variables or assigning or coming up with the values that go into a typical function is slightly more complicated, and you want to keep track of it much better. So one of the ways we can do this is we can start by assembling a tuple, right? So what we can actually do is, let's say we do a bunch of different stuff to create start, middle, and end, and then we want to make it clear that the arguments are start, middle, and end, instead of implicitly passing. So imagine in a real program where you have like a bunch of stuff here, and also another bunch of code here. So obviously for anybody reading your code, it's very hard to kind of see, okay, you know what, start goes into here, middle goes into here, and it all gets lost. So one of the good ways is to actually explicitly declare that the arguments are just of the following, so it's easier to follow. And then what you would do is then use the star operator to unpack the tuple, and you get the same results. So you run this, then you can see that the same result comes up. It's just we took the arguments and we unpacked it. So one of the reasons why you would do this is because there's a lot of code in here that tries to instantiate the value of start, middle, and end, and then so you want to make it explicit that you're passing these into the function, or you're simply assembling this tuple of arguments somewhere else, and then you just pass it through. So you can say, you know, arguments equals to get arguments from another function, and then you would take this arguments and unpack it and put it here. You can also do something like start, middle, end. This unpacks your tuple on this line, and then you can do that instead. So apart from having a lot of code, which you should probably refactor anyway, the other useful situation where this applies is when you have an API call. So the API call returns a tuple, and then you just unpack the tuple into the function, and that's how you call the function. So this happens similarly with a keyword argument function. So if we have keyword arguments, so here we have a keyword arguments a equals to 1, b equals to 2, we return a plus b, so we call keyword functions with its default arguments, then you have 3. So one of the very common ways that you would assemble arguments for this keyword function is you have, like, let's say things to add equals to kind of a, and you would do a bunch of stuff here, maybe call an API call. For a demonstration, let's put 10 here, and then we have b, and then here we have another function, usually, get another API call, something like this. And typically what you would do is then you would do things to add a, and then a equals b equals to things to add b, right? But actually you don't need to do that. All you need to do is use 2 stars to unpack keyword arguments from a dictionary, and you get the magic of this. If you run this, then you can see that it took things to add as the dictionary and then unpacked using the 2 stars operator, and then you can have this. So this, I think, it's a more often seen pattern or trick that you can use where you're assembling a dictionary of arguments and then you're unpacking it into the keyword function. You see this a lot when you're using template functions from Jinja 2, where you have an HTML template and you need to assemble all of the information in your controller to feed into your templates. And so what you would do is assemble a dictionary this way and then unpack it into your templating function, and templating function automatically can get all of this. And having this dictionary syntax is a lot easier to read than having a million keyword arguments like the following. So if you have like more than 4, I think it quickly gets quite confusing. And so if we can use the unpack trick, then we can have all the keyword arguments in a dictionary form, and it's laid out line by line, and it's a lot clearer what's happening. So that's it. So we've now just learned how to call functions with arguments and keyword arguments using the star and the star operator.